It was supposed to redefine amphibious warfare, a machine that could fly across the water, hit the beach like a tank, and outpace anything before it. The Expeditionary Fighting Vehicle, or EFV, was the Marine Corps' moonshot. It could swim like a boat, fight like a Bradley, and move at highway speed on land. On paper, it was unstoppable. In reality, it was a 17-ton heartbreak. After 20 years and billions of dollars, the EFV became a case study in what happens when technology dreams outrun physics. The 1990s were a time of confidence. The Cold War was over, budgets were healthy, and the Pentagon wanted the next leap forward. The Marine Corps envisioned a force that could launch from ships beyond the horizon, safe from coastal missiles, and storm beaches before the enemy could react. To make that possible, they needed something faster than any armored vehicle in history. The plan: an amphibious assault vehicle that could plane over water at 25 miles per hour, 4 times faster than the AAV-7 it would replace. It would carry a squad of Marines, mount a 30mm Bushmaster cannon, and link into a digital network with real-time targeting. The project was bold, and for a while it worked. When the first prototypes hit the water, they looked like the future. A tank surfing the waves. The Marine Corps thought they'd found their silver bullet. To reach those speeds, the EFV had to cheat physics. It used retractable tracks that folded up while in water. A massive 2,700 horsepower diesel engine transformed the hull into a hydroplane, lifting it just enough to skim the surface. It was armor, buoyancy, and horsepower in one impossible equation. Each system was brilliant, individually. Together, they were a maintenance nightmare. The EFV's engine had to generate more horsepower per ton than some fighter jets. That meant extreme heat, mechanical stress, and saltwater corrosion. The unholy trinity of failure for amphibious craft. If a single seal broke, water flooded the electronics. Even small waves could knock it off plane, slamming the hull back into the ocean like a hammer blow. By the early 2000s, reality began to bite. During testing, EFV prototypes failed repeatedly. Engines seized, sensors shorted, hulls cracked. Maintenance hours stacked up. For every hour in the water, it needed 10 in the workshop. Costs ballooned from $4 billion to over $15 billion projected for full production. Even worse, each vehicle's price tag approached $22 million, more than some modern fighter aircraft. At the same time, the battlefield was changing. The wars in Iraq and Afghanistan weren't about beach landings or ocean crossings. They were about city streets, IEDs, and counterinsurgency. The EFV was designed for a war that no longer existed. The EFV's focus on speed created a fatal paradox. To hydroplane, the vehicle needed to be light. This severely compromised the heavy armor needed for ground combat. It was designed with a flat bottom, perfect for water speed, but a death trap against modern threats. Every IED blast channeled its force directly into the crew compartment. The wars in the 2000s demanded a mine-resistant ambush-protected vehicle, an MRAP, but the Marines were trying to build an amphibious race car. They had prioritized mobility over life itself. The required armor package to survive Iraq would have made the EFV too heavy to plane over water, sinking the entire concept before it ever launched. In contrast, the ACV that replaced it features a specialized V-shaped hull, directly inspired by the successful MRAP design. This V-hull deflects blast energy outwards, protecting the 13-man squad inside.
Listen up, we're slowing down. Hatch detail, prepare to move.
The final lesson was brutal. Survivability on the ground is non-negotiable. The irony is profound. To succeed on the land, they had to ditch the very feature that made the EFV revolutionary on the water.
Good afternoon. I am here today to announce the formal cancellation of the Expeditionary Fighting Vehicle program. This decision was not made lightly.
The official reason was cost. Unsustainable, they said. Unofficially, it was physics, maintenance, and mission drift.
It couldn't survive
rough seas, it couldn't survive budget politics, and it couldn't survive a world where beach assaults looked like suicide missions. Defense Secretary Robert Gates summed it up bluntly. The EFV does not provide the needed capability at the needed cost. 2 decades of development ended with a press release, and a pile of prototypes gathering dust. But failure doesn't always mean useless. The EFV proved that high-speed amphibious vehicles were possible, just not practical yet. Its hydrodynamic hull design became a study model for later vehicles. Its digital battle network concept lived on in the Marine Corps' tactical service architecture, connecting troops, drones, and sensors. Even the V-shaped hull, now standard on many armored vehicles, was refined through EFV testing. In other words, the EFV failed forward. It taught engineers how to think like sailors and soldiers at the same time. Beyond the tactical failures, the EFV's death was a slow execution by logistics. Its complexity created a logistical black hole for the Marine Corps. Imagine a mechanic needing to be fluent in naval engineering, high-performance racing engines, and tactical software, all to fix one vehicle. The parts inventory required was enormous, often custom-made, and impossible to quickly stock in a forward operating base. This meant EFVs were often sidelined for months. This downtime destroyed unit readiness. A force cannot depend on a vehicle that spends 90% of its life waiting for a replacement seal or a specialized technician. The ACV is built on proven commercial components. Its engine is easily sourced. Its systems are simplified. The Marines consciously chose dependability over exotic performance. When the EFV was scrapped, the Marines didn't abandon the sea. They just stopped trying to outrun it. The Amphibious Combat Vehicle, or ACV, that followed represents everything the EFV wasn't. Slower, heavier, but far more reliable. The Marines traded hydro speed for durability. The ACV doesn't skim the water, it pushes through it, deliberately, predictably, and without breaking down. It's proof that the Corps learned the EFV's hardest lesson. You can't engineer your way out of reality, you can only design for it. Ironically, the EFV's original dream might yet return, not as a manned vehicle, but as an autonomous assault craft. Advances in materials, AI, and electric propulsion could one day make high-speed amphibious armor feasible again. Imagine drone swarms launching ahead of Marines, scouting, breaching, and delivering supplies at 40 knots. That vision isn't dead. It's simply waiting for technology to catch up. Just as the EFV was ahead of its time, the future might finally belong to its descendants. The Expeditionary Fighting Vehicle was a masterpiece that drowned, a symbol of how ambition and engineering can collide head-on with reality. But from its wreckage, the Marines built something humbler and far more lethal. Because progress doesn't always roar across the waves, sometimes it crawls through them, one lesson at a time. Outro narration. Don't forget to hit that like button and subscribe to US Warfare Desk to track the critical technology shaping the wars of tomorrow. Thanks for watching.